Welcome to the Ergonomics training module. This module will cover the following topics: musculoskeletal disorders, motion-based risk factors, physical risk factors, environmental risk factors, psychological state risk factors, musculoskeletal disorders prevention, and engineering and administrative controls. This module will introduce you to the subject of ergonomics and musculoskeletal disorders, or MSDs. Every year, thousands of workers are injured, not in sudden single incidents, but over time as a result of the physical requirements of their job. Because of poor workplace design and/or unreasonable expectations placed on them, these workers end up injured and unable to work. This module will examine what leads to this kind of injury and how the study of ergonomics can be applied to minimize or eliminate these problems. Musculoskeletal disorders describe injuries or illnesses that affect one or more parts of the muscle and skeletal parts of the body. The injuries include sprains, strains, inflammation, degeneration, tears, pinched nerves or blood vessels, bone splintering, and stress fractures. Symptoms of these injuries include pain, fatigue, swelling, stiffness, numbness, and tingling. These problems are generally the result of a gradual or chronic development, although sudden events such as trips or falls may also lead to an MSD. MSDs are usually defined primarily by the location of the pain. Musculoskeletal disorders are a significant economic issue. Back injuries are the leading cause of disability for people under 45 years of age. Lower back pain accounted for 23% of the total, or $8.8 billion worth of workers' compensation payments in 1995. According to the Bureau of Labor Statistics, there were 582,000 MSDs that resulted in employees missing time from work in 1999. While it is harder to quantify, MSDs also decrease both productivity and the quality of services and products. Workers experiencing aches and pains on the job are not going to do high-quality work. Finally, MSDs reduce the quality of life both on and off the job for those who are afflicted. Ergonomics is the solution to the MSD problem. According to the Merriam-Webster Dictionary, ergonomics is the applied science concerned with designing and arranging things people use so that the people and things interact most efficiently and safely. Ergonomics considers the physical and mental capabilities and limits of the worker as he or she interacts with tools, equipment, work methods, tasks, and the working environment. Although the scope of ergonomics is quite broad, the term in this introduction to the subject will refer primarily to understanding workplace factors that may pose a risk of musculoskeletal disorders and how those factors might be reduced. A risk factor is any condition or situation which increases the possibility of an unfortunate event. The risk factors which can lead up to an MSD can be broken down into three groups: the motion-based activities of a job, the physical environment in which the work takes place, and the psychological state of the worker and people around him or her. The area where the factors overlap represents the highest threat to workers. The motions required by a given task, combined with the physical area that job must be performed in, pose the greatest potential risk to a worker. Job activity risks can be broken down by category: awkward postures, forceful exertions, repetitive motion, duration, vibration, and contact stresses. Body posture determines which joints and muscles are used in an activity and the amount of force that is generated on a given body part. For example, handling objects with the back bent or twisted places more stress on the spinal discs as compared to the same task with the back kept straight. Holding or lifting an object at arm's length puts more stress on the back than holding the same weight close to the body. Activities requiring frequent or prolonged work over shoulder height can be particularly stressful. Even a non-demanding task, such as typing, can cause bodily stress if performed in an awkward or improper position. Tasks that require forceful exertions place high loads on the muscles, tendons, ligaments, and joints. Prolonged or recurrent muscle exertion may cause fatigue and may also lead to musculoskeletal problems if there is inadequate time for rest or recovery. If motions are repeated frequently for prolonged periods, fatigue and muscle tendon strain can accumulate. Tendons and muscles can often recover from the effects of repetitive motion if sufficient time is allotted between exertions. This accumulation of strain can occur even with small repeated motions, such as typing or small-scale assembly. Duration refers to the amount of time a person is continually exposed to a risk factor. Job tasks that require use of the same muscles or motions for long durations increase the likelihood of both localized and general fatigue. In general, the longer the period of continuous work, the longer the recovery time required. Repeated or continuous contact with hard or sharp objects may create pressure over one area of the body and inhibit nerve function and blood flow. Contact stress risks range from resting your arm on non-rounded desk edges to the continual use of unpadded, narrow-handled tools. Exposure to local vibration occurs when a specific part of the body comes in contact with a vibrating object, such as a power hand tool. Exposure to whole body vibration can occur while standing or sitting in vibrating environments, such as when operating heavy-duty vehicles or large machinery. Many of these risk factors are cumulative. For example, a lifting job which is not inherently difficult may pose a significant risk if the worker must turn or twist as the lift is being made. A simple lift may also become hazardous if it is repeated too many times without adequate recovery time. The physical workspace in which one must work can have a great impact on one's ability to work safely and effectively. Whether it is a mismatch between chair and desktop height or a floor-level bin from which something must be pulled every minute, the location and placement of objects can lead to an increased risk of MSDs. The general conditions of a workplace can additionally impact a worker's well-being. A worker who must compensate for an environment which is extremely hot, cold, dirty, noisy, or insufficiently lit will have an increased risk of an MSD as well as being less productive. The last category of threat to workers includes a blend of social attitudes and mental states. A work culture might discourage an individual from taking the time or using the proper equipment to avoid injury. For example, wearing a back supporter for lifting moderate loads might be considered weak by coworkers. The mental state of a worker can also pose a risk. While no direct mechanism has been determined, researchers have shown an increased incidence of MSDs in workers in high-stress jobs. Many factors can contribute to stress in the workplace, including feelings of lack of control, being forced to work at too fast of a pace, or insufficient rest breaks. Most workers bring some degree of stress from home as well. There are as many ways to address MSD threats as there are jobs and situations which present them. The actions to prevent MSDs can be classed as either engineering controls or administrative controls. The next sections will examine these preventive measures in more detail. The preferred approach to prevent MSDs is to address the physical aspects of a job's risk factors. This approach includes considering the workstation layout, the selection and use of tools, and work methods. Examples of engineering control strategies for reducing risk of MSDs are changing the way materials, parts, and products are transported. For example, using mechanical devices to relieve heavy load lifting and carrying tasks, or using handles or slotted handholds in packages that require manual handling. Changing the process or product to reduce worker exposures to risk factors. Examples of this include maintaining plastic molds to reduce the need for the tedious manual removal of excess flashing, or using Easy Connect electrical terminals during assembly to reduce the required manual forces. Modifying how parts and materials are presented and accessed. This can be as simple as tilting or adjusting the height of frequently accessed parts or material bins. Changing workstation layout, which might include using height-adjustable workbenches or locating tools and materials within short-reaching distances. Changing the way parts, tools, and materials are to be manipulated. Examples include using fixtures such as a vise or clamp to hold a workpiece, which relieves the need for awkward hand and arm positions, and suspending tools to reduce their effective weight while allowing the worker easier access to them. Changing tool designs. For example, pistol handle grips for knives to reduce wrist bending postures required by straight-handled knives, or squeeze grip actuated power screwdrivers to replace finger trigger actuated screwdrivers. Administrative controls are management-dictated work practices and policies to reduce or prevent exposures to ergonomic risk factors. Although engineering controls are preferred, administrative controls can be helpful as temporary measures until engineering controls can be implemented, or when engineering controls are not technically feasible. Since administrative controls do not eliminate hazards, management must assure that the practices and policies are followed. Examples of administrative control strategies for reducing risk of MSDs are reducing shift length or curtailing the amount of overtime, rotating workers through several jobs with different physical demands to reduce the stress on limbs and specific body regions, scheduling more breaks to allow for rest and recovery, adjusting the work pace to relieve repetitive motion risk and give the worker more control of the work process, establishing job exertion limits. For example, the National Institute for Occupational Safety and Health, NIOSH, has established a lifting model that determines the maximum load that can be safely lifted, taking into account how the load is positioned with respect to the body, the starting and ending positions of the load, the frequency of the lift, and the duration of the lift. Musculoskeletal injuries present a health threat to affected employees and pose an economic threat to their employers. Fortunately, the use of ergonomic principles and good workplace planning can significantly reduce those risks.